A major U.S. bank had a regression model with R-squared of 0.91. The model looked perfect. Then 2008 happened. DW statistic, 0.64. Serial correlation was screaming in the output. Nobody read it. $32 billion in mortgage securities, written down to near zero. This lesson is about reading regression output the way a CFA charter holder reads it. Every cell, every number, no surprises. Quantitative methods is 6 to 9% of your Level 1 exam. That is 11 to 16 questions. Regression interpretation is explicitly listed as a testable learning outcome statement, and the exam always gives you the output table already computed. Your job is not to derive formulas. Your job is to read the table and answer correctly in under 90 seconds. Simple linear regression models the relationship between one dependent variable y and one independent variable x. The equation is y hat equals b0 plus b1 times x. b0 is the intercept, the expected value of y when x is 0. b1 is the slope. For every 1 unit increase in x, y changes by b1 units. The exam tests exactly one thing here. Can you tell the slope from the intercept, and can you state what 1 unit of x means for y? The OLS regression line. Y hat equals b0 plus b1 times x. b0 is the intercept, the expected value of y when x equals 0. b1 is the slope, the expected change in y for a 1 unit increase in x. On the exam, you will be given b0 and b1 directly from the output table. You will not derive them, you will interpret them. How does OLS calculate the slope? b1 equals the covariance of x and y, divided by the variance of x. Know this formula, not the derivation, just the ratio. Covariance over variance. If covariance is positive, the slope is positive, they move together. If covariance is negative, the slope is negative, they move in opposite directions. Walk through a real regression output. Tesla XS returns regressed on S, and P500 XS returns over 5 years. Step 1, the coefficients column. Intercept equals 0.012. Slope beta equals 1.85. Step 2, the standard error column, measures uncertainty around each coefficient. Step 3, the t-statistic column. Beta t-stat equals 8.7, compare to critical value of 1.96 at 5%. 8.7 is way above, beta is highly significant. Step 4, p-value column. Below 0.05 means significant. Step 5, R-squared equals 0.42. 42% of Tesla's return variation is explained by the market. Step 6, F statistic equals 75.7. The overall model is significant. R-squared. The coefficient of determination. R-squared equals RSS divided by TSS, regression sum of squares over total sum of squares. It equals 1 minus SSE over TSS. The range is 0 to 1. 0 means the model explains nothing. 1 means the model explains everything. The exam trap, R-squared of 0.85, does not mean the slope is statistically significant. And it absolutely does not mean X causes Y R-squared is a proportion of variance explained, nothing more, nothing less. Standard error of estimate C. C equals the square root of SSE divided by n minus 2. It measures the typical distance between observed Y values and the regression line. Smaller c means the line fits tighter. Larger c means wider scatter around the line. The exam tests c as a precision measure. A regression with c of 2% versus one with c of 8% is much more useful for prediction, everything else equal. The F statistic tests overall regression significance. F equals RSS over K, that is the mean regression sum of squares, divided by SSE over n minus K minus 1, the mean squared error. The degrees of freedom in the numerator equal K, the number of independent variables. The denominator degrees of freedom equal n minus K minus 1. The null hypothesis for the f-test, all slope coefficients simultaneously equal 0. This is the most tested trap in this entire topic. The null is not, at least one coefficient equals 0. The null says all of them are 0. Rejecting H0 proves the model has overall significance, but it does not tell you which individual variable is significant. The t-test for individual coefficient significance. T equals b1 minus 0, divided by the standard error of b1. This tests one question, and one question only. Is this specific coefficient statistically different from 0? Compare the t-statistic to the critical value. At 5% significance with large samples, the critical value is approximately 1.96. If the absolute value of t exceeds the critical value, reject H0, the coefficient is significant. If it falls below, the variable cannot be proven to have any effect. The most tested distinction in regression, f-test versus t-test. Left side f-test tests all slope coefficients simultaneously. Null, every slope equals 0. One test, one conclusion about the whole model. Right side t-test tests one coefficient at a time. Null, this specific slope equals 0, as many t-tests as there are variables. The exam trap. A significant f-test does not mean all t-tests are significant. A single powerful variable can drive the f-test to significance, while other variables remain individually insignificant. These are two separate hypotheses, two separate conclusions. Multiple regression adds more independent variables. The model becomes y equals b0 plus b1 x1 plus b2 x2, and so on. Adjusted R-squared solves a critical problem. Regular R-squared mechanically increases every time you add a variable, even a useless one. Adjusted R-squared penalizes for additional variables using n minus k minus 1 in the denominator. If you add an irrelevant variable, adjusted R-squared will decrease. Regular R-squared will stay flat or increase. Use adjusted R-squared when comparing models with different numbers of independent variables. Always. Multicollinearity, the three-part fingerprint. The scenario. You add inflation and GDP growth as independent variables to predict bond yields. Step 1, R-squared equals 0.85. The model looks great. Step 2, f-statistic significant, p-value of 0.0001. Overall model is significant. Step 3, individual t-statistics. Inflation t-stat equals 0.62. GDP growth t-stat equals 4.21. Inflation is completely insignificant. That is the multicollinearity fingerprint. High R-squared, significant f-test, individually insignificant t-stats. Why? Inflation and GDP growth are correlated with each other. The model cannot separate their individual contributions. The fix, check the correlation matrix. If two independent variables have correlation above 0.7, suspect multicollinearity. Exam question. A regression of quarterly portfolio returns on market returns produces. Intercept equals 0.5, slope equals 1.2, R-squared equals 0.72. Which best interprets the slope coefficient of 1.2? Option A. For every 1% increase in market returns, portfolio returns increase by 1.2%. Option B. The portfolio has a 1.2% expected return when market returns are 0. Option C. 72% of the variation in portfolio returns is explained by market returns. The exam tests exactly one thing here. Can you separate the slope, the intercept, and R-squared? The answer is A, the slope, B. 1 equals 1.2 means 1 unit of x produces 1.2 units of y. Option B describes the intercept. That is 0.5, not 1.2. Option C describes r squared. That is 0.72. 3 different numbers, 3 different meanings. The exam puts all 3 in one problem, hoping you confuse them. Harder question. A multiple regression with 3 independent variables shows regression SS equals 240, residual SS equals 60, n equals 25. What is the F statistic, and what is the null hypothesis? Option A, F equals 4, null is at least 1, slope equals 0. Option B, F equals 26.67, null is all slope coefficients simultaneously equal 0. Option C, F equals 4, null is the slope on the first variable equals 0. The answer is B. F equals RSS over K divided by SSE over n minus K minus 1. That is 240 over 3 divided by 60 over 21. Equals 80 divided by 2.857 equals approximately 28. The null hypothesis for the F test says all slope coefficients simultaneously equal 0. The phrase, at least one coefficient equals 0, is the alternative hypothesis, the exact opposite. This is the most commonly failed exam trap in this entire topic. Third question, the multicollinearity paradox. A regression output shows r squared equals 0.85 and a p-value on the slope coefficient of 0.42. Which conclusion is most appropriate? Option A, the model is a strong predictor because r squared is very high. Option B, the high r squared combined with insignificant coefficient is a warning sign of multicollinearity. Option C, because r squared is high, the slope must be statistically significant. The answer is B. A p-value of 0.42 on the slope means we cannot reject the null that b1 equals 0. The coefficient is not statistically different from 0. High r squared does not imply significant coefficients. In a multiple regression with correlated predictors, this exact combination, high r squared, insignificant t-stats, is the hallmark of multicollinearity. Exam strategy for regression output questions. When you see a regression table on the exam, read it in this exact order. 1. Coefficients column. State the direction and magnitude. For every 1 unit of x, y changes by b1. 2. T-statistic column. Compare to 1.96 at 5%. If below, that variable is not significant. 3. P-value column. Below 0.05 means significant. 4. R squared. Proportion of variance explained, nothing more. 5. F statistic. Is the model as a whole significant? State the null, all slopes equal 0. 6. DW statistic. Near 2 is fine. Below DL means positive serial correlation. Above 4 minus DL means negative serial correlation. Between DL and DU is the inconclusive zone. If this output was on your exam tomorrow, you would read every cell in under 90 seconds and get it right. Screenshot this. Your complete regression cheat sheet. Everything tested on the CFA level, one exam on one screen. Save this, study this, come back to this the morning of the exam. If this was on your exam tomorrow, you would get it right.